In this video, I'm going to do a review of exponents. It's going to be really important that you can work with exponents very fluently, that you understand the definitions for the various types, like negative exponents and fractional exponents. And in the first, I just want to show you why it's going to be so important, and then we'll do just a reminder about exponents. All right, so if you have a function like f of x equals 2x to the fifth, in our next unit, we're going to be learning how to do the derivative of this quickly and easily, just using derivative rules rather than doing the limit of the difference quotient. All right, one of the rules that we use so much that's so important is just the power rule. And so it's used when you have an exponential expression like x to the fifth, something like that. All right, so when we do this, we're going to actually be using a combination of a couple rules. The one that tells us what to do about the 2 that's out in front, and then one that tells us how to handle an exponential expression. All right, so for the power rule, or to do the derivative of this, it's going to be as simple as knowing that the constant multiple can just be brought down. And then when you do the derivative for the x to the fifth, you bring the exponent down in front, and then you're going to wind up taking 1 away from the exponent, and then you just simplify that. So that winds up equaling 10x to the fourth, and you're done. Okay? You've just found the derivative of that function. All right, so that works great. Well, what's even better is when you have a function that's even more complicated that doesn't look like you'd be able to use that rule, it's going to turn out that you can. So if we had something like, say, 4 over the square root of x, if we're able to take that and rewrite it so it looks like this right here, has that same look, then we can just use the power rule to wind up doing the derivative. So that's going to involve understanding that a square root is the same as raising something to the 1/2 power. So you take a moment to work through that. So square root of x is the same as x to the 1/2. And the x to the 1/2 is in the denominator. So that could have come from having a 4x to the negative 1/2. Okay? So we're going to work with exponents so that we can learn to do that. Because if you can rewrite your function so it looks like this, constant out in front, variable raised to a power, okay, then you'll be able to use the rule that we did on the f function here. We do the same thing. So to do the derivative of g, the constant can just be carried along. Then we're going to multiply by negative 1/2, then take the x to the negative 1/2 and subtract 1 from the exponent. Okay. So then we're going to work on simplifying this a little bit. The 4 times the negative 1/2 would be negative 2. Negative 1/2 minus 1 is negative 1/2 minus 2 over 2, so that'll be negative 3/2. And then you won't leave your answer that way. You'll get it back into radical form. So we'll go through that process. The negative 3/2 applies only to the x, so we'll be able to rewrite that as negative 2 over x raised to the 3/2 power. The negative exponent tells you to do the reciprocal. The negative 2 stays on top, though, because it's understood to be to the first power. All right, and then we'll keep going with the rewriting step. So the negative 2 is here. And then we'll be reminded in a moment that x to the 3/2, that fractional exponent means you've got a radical that's actually a square root. The x would be underneath, and then it's raised to the 3rd power. And you could put it here, or you could have put it underneath with the x. Okay? So it's going to be important that we can take something that doesn't look like the power rule would apply and change it into something that looks like the power rule would work. And then we can use that rule to do the derivative. So let me go ahead and do a little bit of the review of exponents worksheet. So pull that out, and we're just going to review a few things. All right, so let me go ahead and just look at the top two, and then I'll, maybe I'll go through. Let me get through question number 10, and then I'll do another video on the remaining parts. So on 1 and 2, people misinterpret this all the time. First off, you should know that something raised to the third power, that the x is the base here. Ooh, why is it so big? Let me go back. So the x is the base and the 3 is the exponent. So the 3 tells us that we should multiply x times itself 3 times. Okay, the base times itself 3 times. Now, questions 1 and 2 are misinterpreted all the time, and you've got to get this straight. On question number 1, the base is actually the 3. The 2 only applies to the 3. The negative is like taking the opposite. So on number 1, you should be doing the opposite of the square of 3. You know, it really means -1 times 3 times 3. It's going to turn out to be square the 3 and get 9, and then take its opposite. So it's a -9 when you're finished. Where question number 2, you're squaring the opposite of 3. It's like the order of those two operations is different. The negative is taking an opposite. The 2 is squaring. On question number 2, we do the opposite first and get -3, and then square it, multiply it times itself. And a -3 times itself would be +9. Okay, so the answer is 9 there. All right, a few other things to be reminded of. X to the first power is the same as x. X to the 0 power would equal 1, except if the base were 0. That is indeterminate. With some patterns, it would be nice for that to equal 0, and then for other patterns that we encounter, it would be nice for that to equal 1, and so we can't say it's equal to any particular thing. Now these next 3 have negative exponents. Negative exponents are not going to turn out to be negative numbers. Okay, x to the -1 means 1 over x. X to the -2, 1 over x to the first, but that would just be 1 over x. X to the -2 is 1 over x squared. All right, now try number 7 before you see me do it. Think about what you think that is. It's really common for people to think this. Is that what you thought when you tried it? That's incorrect, because the base of that exponent is really just x. The 3 is really to the first power. Only the x is being raised to the -4th power. So the 3 would stay, and then you would do 1 over x to the 4th and get 3 over x to the 4th. Okay. All right, and then the other type of exponent we need to talk about is fractional exponents. And you got a glimpse of this when I was kind of showing you why being good with your exponents is going to be so helpful. X raised to the 1/2 power is exactly the same as doing the square root of x. The denominator tells you what kind of index, what kind of root you're taking. And just because it's a square root, we don't really have to write it. But notice on number 9, we have a 3 in the denominator of the fractional exponent. The 3 tells us this is going to be a cube root. X is the base, so that's going to be underneath the radical. And then with the 2, we can put it here, or we can do cube root of x squared. Those have the same meaning, because this could have been interpreted as x squared raised to the 1/3 power, or x to the 1/3 first, then squared. Those are equal, and because of the properties of exponents, that would have been the x to the 2/3 that we started with. So either of those are okay, on question number 9. Now, with question number 10, I did a fractional exponent, but also had a negative. So there, be thinking about the negative means this, And then the fractional exponent is the same as a square root. Okay. I'm going to stop it so the video doesn't get too long, and I'll do the rest on another video.